Hello, welcome to this AQA Further Maths Statistics video, the second in the series looking at confidence intervals. So a quick reminder here from what we looked at in the first video in this series, that when we are looking at a population that's normally distributed, mean, mu, variance, sigma squared, the sample means are distributed also normally with mean mu the same as the original population, but variance sigma squared divided by n. And if we look at how we could estimate an unknown population mean from having a sample, I think the obvious way of obtaining an estimate for the population mean mu would be to obtain the sample mean, and this is called a point estimate. For the population mean, it's a single value. The problem with the sample mean as a point estimate, as just one single value to give us an idea of the population mean, is that it's very unlikely that x bar is going to equal our population mean. And we also don't really know that much from our point estimate about the actual population mean, how much larger or smaller than our point estimate it might be. So we don't have that information about the accuracy of our estimate if we only have one value to go on. So this video is going to be looking at an interval estimate rather than a point estimate, and this is what we call a confidence interval, and we're going to be looking at it for mu, the population mean. And a confidence interval gives us a range of values together with a probability that that interval contains the actual value for the population mean mu. So a confidence interval will have two things attached to it. It will produce a range of values that we normally would write in this way, and it will also have associated with that a level of confidence or a probability, and normally that will be written as a percentage, and most usually we have a 95% or a 99% level of confidence. So what do we mean about levels of confidence, or these 95 or 99% probabilities? Well, these relate to the fact that sample means are normally distributed. We're going to be using our sample mean, and we're looking at the fact that with a 95% interval, and that means we're capturing the central 95% of possible values for a z-score, 95% of those will lie between plus and minus 1.96. And so if we're talking about a 95% interval, you're going to need to be able to use and obtain that z-score 1.96, and similarly obviously a wider interval here. If we want 99%, then we're going to be looking at z-scores of plus and minus 2.56, and it's important that you can obtain these from your calculator so that you know which z-scores are the one to use depending on the level of confidence involved. And what we know then is that for our random sample with known variance sigma squared, an unknown population mean mu, we know that any sample mean will lie between mu plus our z-score 1.96 multiplied by its standard deviation sigma over root n, and similarly mu minus 1.96 multiplied by sigma over root n, with that probability 0.95. And this is the basis for constructing the confidence interval. And if we rearrange each side of that inequality on the previous slide, then we obtain the fact that our unknown population mean mu will lie between x bar, our sample mean, plus or minus 1.96 multiplied by sigma over root n, with probability 0.95. And this is the important formula here or statement to remember when constructing confidence intervals. And here we have it summarised. And what do we know about our confidence interval here? We know that approximately 95% of such intervals will contain the unknown population mean mu. So we are talking about a probability of 0.95 of a confidence interval evaluated from our population containing the actual population mean mu. And this can be a slightly awkward concept to grasp in that what we're looking at are lots and lots of confidence intervals, and there's a little applet here that you can actually follow the link and have a play with this yourself, and you can see here you haven't got all the confidence intervals demonstrated, but the green line indicates the population mean, the blobs indicate the sample means, and you can see that we did actually have a couple of confidence intervals here that didn't contain our population mean, and I'll just demonstrate that with you now. There we have a little look here at this applet in action for 95% confidence interval, sample size 50, and you can change that if you want to. If we take a few samples, you can see in yellow the values from the population that have been sampled at random. This one's very spread out. And you can see these intervals so far, they are all capturing our population mean. And here we have a sample where our confidence interval constructed from this sample is not capturing the population mean. But overall, you'll find that 95% of such intervals will capture the population mean. So if we look at an example now, so we have here 16 fish being weighed in grams by a fish farmer. So it's worth just noting those values down and perhaps put them in your calculator so you can evaluate this interval yourself. And we're going to find a 95% confidence interval for mu, the population mean. How can we do that when we know the standard deviation of the weights of such fish is 80 grams? And whenever we are using a sample from a population to evaluate a confidence interval, we must know or be able to assume that our sample is random. So the first thing to do would be to evaluate the mean, the sample mean for this particular sample here from your calculator, and then we use that formula using a z-score of 1.96 because it's a 95% confidence interval. So we use the formula to evaluate our confidence limits, our confidence interval, and it's very often written plus or minus in this form, and then we can write our interval in brackets in the way I demonstrated before, and that 514.8, 593.2 is our 95% confidence interval for mu. And if you have a graphics calculator in statistics mode, you'll see a button int, and from that you can work out your confidence interval directly. What does that confidence interval mean? So we've evaluated it. So imagine our fish farmer claims the mean weight of his fish is 600 grams. So it possibly doesn't seem unreasonable looking at the data. We do actually have 4 fish in his sample that weighed more than 600 grams, so possibly 600 grams could be correct. But if we look at the confidence interval, what does that tell us too? And so there are 2 things that we can say when we look at the farmer's claim. We could just state quite definitely that 600 doesn't lie within the confidence interval. In fact, it's above it, and therefore the mean must be lower than 600 and his claim is not true. That's far too definite, and it might be a comment you'd like to make that 600 doesn't lie within the confidence interval, but really the rest of this final sentence is not something you can state as definitely being the case. What we do know is that 600 doesn't lie within the 95% confidence interval, and 95 of such intervals will contain the mean, so it seems unlikely that the mean weight is 600. In fact, it looks as though the mean is probably lower than that. And that's the end of this video.